Hello everyone, welcome to a new video. So today we will be explaining how we can communicate and start the drive ACS800 drive from Siemens S7 PLC. So this video will be a continuation from my before video. So I did a video about ACS800 basic commissioning. So this video will be a continuation from that. Okay. So let's first configure this drive for the profibus connectivity. So you need to go to 98 group and you need to define the field bus. We are using RPBA field bus controller for communicating with profibus. Okay, so let's select field bus and make sure this is in ABB drives, because if you select others this will change the complete status word and control word structure. So always select this. Now you can see this drive. The profibus parameters will be in parameter group 51, but as you can see 51 is not here because we just enabled field bus. So what you have to do is you need to double count parameters, you need to refresh. Okay, now if you open you can see group number 51. Okay, so here you can define the node address. You can define any profibus address as you require. So I'm going to keep it at 3. Baud rate you can keep it at 1500, and PPO type we can keep it at 4. So whatever you define here you need to define in the PLC as well. So by doing this the profibus connectivity is done. Okay, and very important parameter, the DP mode should be in, you need to keep this in 1, otherwise it will not work. So for each change you need to refresh here. Okay, so now we configured the drive for profibus connectivity. So now let's go to the PLC side. So open the schematic manager. I already created the hardware, basic hardware. So I have a S7400 PLC. You might have S7300 as well. You can do the same procedure. So let me create a profibus network. So create a new profibus network. Okay. Now you need to install the GST file for this ACS800. So as I told you, I am using this RPBA card. So you can download this from directly from ABB website. Just Google search for ABB RPBA GST. You'll find the GST file here. You can download. So I already did that. So you can install here, like install the once you download the GST file, go to install, then search for your where you have located. So the file looks like this, ABB10812. So just click install and this GST file will be installed. If you face any difficulty like installing this GST file, what you can do is that you can close everything, just make a new project without any hardware on it and just install, and you will not face any difficulty. So once you install, just search for ABB and you'll find your RPBA here. So you can put it here and define the station address. So my address is 3, speed is 1500, so everything okay. Okay, now we need to in the drive, if you see the node address 3, PPO type 4. So we'll call the same PPO type here, PPO type 4, put it here. Okay, now we can compile and we can download and see. Okay, okay, we'll restart. So it is downloaded. Now we can go online and you can click here, go for monitor modify, and if you click monitor you can already see there is some values coming from the drive. Okay, so PPO type 4 means you have 6 inputs and 6 outputs. Okay, so this first input will be the status word, and second input will be the speed feedback, and your first output will be the control word, and second output will be the speed reference to the drive. So input means drive to PLC, output is PLC to drive. So what you are receiving here is status word from the drive. You are already receiving some values from the drive. That means your profibus connectivity, everything is okay. Okay, so now we will close this, or let's keep it open. Okay, the same thing. So as you can see here, uh, the value 512 and 514, that is supposed to be the PZD3. Okay, I'll explain this. So PZD3 out means this is the third uh, output, means drive, sorry, PLC to drive. Okay, PZD3 output means this is the third output for the PLC to drive. PZD3 in means this is the third input, that is drive to PLC input. So you'll be wondering where this is, the first two inputs. Actually you don't need to define that here because it is predefined, which means the first input is always the status word, second input is the feedback, and first output is the uh, control word, second output is the speed reference. Okay, so our drive and PLC profibus configuration is done. Now we will change some values in the drive to start the drive from PLC. So first thing you need to do is you need to go here, 10th group, which is the start command. So you need to change this one to command word here. Okay, and if you want to run the drive positive and negative reference, that is forward and reverse, you need to keep this in request. Okay, now the speed reference. So go here, you can keep it as external one, and you can change this to communication reference. Okay, so now this is done, means your drive side is ready for accepting the start command from PLC and the reference from the PLC. Now we will go to PLC program. So if you want you can put these OB blocks, because this depends on your requirement. If you have some IO fault, track fault, everything, this will bypass all that. So if you want you can keep this OB, just add this OB number 82, 85, 86, 121, 122, otherwise leave it. Okay, so we will write the program in OB1. So as I said, the card that we are using is RPBA card. So you can download the manual and you can go to this page where you can find the command word or the control word and the status word. Okay, the first thing what we will do is like uh, we will decode this status word. So this is the status word. So you can see there are status word is a word that sent by the drive. It is a 16-bit word. Okay, so this is the first 8 sorry, this is the first 8 bit and this is the second 8 bit. Okay, so we know our status word is coming from PAW 512. So let's load. Okay, so we moved the status word to a memory variable that is MW50. So why I did this is because the as I said, there are 16-bit word, first 8-bit and second 8-bit. So always you need to remember whenever there is a transfer from drive to PLC or PLC to drive, there is always a byte swap. So the second 8 bits will come as a first 8 bit to the PLC and first 8 bit will come as a second 8 bit to the PLC, which means if I move this status word to MW15, MW15 means memory byte 50 memory byte 51. Okay, first 8 bit, second 8 bit, but since there is a byte swap, the first bit actually will come in M51.0, the second 8 bit will come in M50. So here what I mean to say is the first bit of the status word, that is ready on, this will be M51.0. A51.0, sorry, AM51.0 will be equal to your first bit. So you can make some temporary variables here, like I already made ABB ready for on, because I want to keep the same name as in the manual, ready for on, ready for on. Okay, so you can okay, so the second bit will be M51.1, which is the ready for run. Ready for run. So I already prepared this, I'll just copy paste this. Okay, so this will decode our status word. So status word is important, it is very important to find out the drive, like troubleshoot the drive. If there is some problem with the drive, you can always depend on the status word bits to troubleshoot something. So whatever in the defined in the manual, I already defined in the program. Okay, so now we have done with the status word. Now we'll go with the control word. So before going to the control word, we will make a always high bit. So this is the status word. I'm not using a M0.3 anywhere, so I'll use this bit to make a always high bit. So M0.4 will be always 1. Okay, now we'll go with the control word. Okay, we know our control word is being sent from PLC to drive on this PQW 512. Okay, so PLC to drive. So let's say I'm going to load from MW60 to PQW 512. Okay, so PQW 512 will hold the control word. So again, there is a byte swap. Like if I have to say MW60 means memory byte 60 and memory byte 61. So due to a byte swap, so MB memory byte 61 means what? M61.0 to M61.7. Okay. So M61.0 to M61.7. This means M60.0 to M60.7. So what I mean to say is, like, due to the byte swap, your first control word bit, that is off on control. This is your first control word bit. So this we need to send from M61.0. So M61.0 will be the first control word bit. Okay, and the 8th bit will start from M60.0. So let's say okay, before that the control word explanation. So we will use this bit to start the drive. Okay, so off 2 off 3, which is the like an emergency stop or fast stop. So this bit, if you have some e-stop or some very high priority fault, you can connect to this bit, or if you don't have, just bypass this bit by writing 1 to this bit. Okay, operation enabled should be true, ramp out 0 should be true, ramp hold should be true, ramp in 0 should be true, and reset, you need to define a separate bit for reset to reset the drive whenever there is a fault. Inching, if you have inching, or you can connect the bit here, or you can keep it false. Remote command should be true, which means we are going to run the drive from field bus. And 11 to 15, this you can keep it as false, because this is a drive specific, like external control, some meaning is there, but just for the basic setup you need to keep all this as false. So I already prepared this. Okay, so this basically means AM0.1. So we will be using M0.1 to start the drive. Okay, and M0.4 is the always high bit, so I'll be bypassing all this. And the 7th bit, that is the reset command. So if we go to the 7th bit, this is the reset command. So I use M0.2 to bypass to reset. Like if I force this M0.2, it will give the reset command to the drive. And not means false, so I am not using inching function, so I keep these two as false, and the 10th will be the true, because this is a remote command. So I use 10th bit, this is true, and after that you can see all are dry specific, so we are not going to use, so we will keep all these bits as false. So now when you combine all this, we will get MW60. Okay, so once this is coded, you can just transfer you to the actual control word. So this is done. Now the speed feedback and the speed reference. Speed feedback. So the speed feedback comes from PAW514, and you need to divide the value will be in percentage, so you need to divide by 200 to get the value from 0 to 100%. Okay, okay, so let's load this. PAW514 200 divide. So what I did is I loaded the speed feedback, that is PAW514, then I divide by 200 and I will make as integer and transfer to memory word 10. Okay, now speed reference. Speed reference is what we are sending from PLC to drive, so the second word will be the speed reference. So let's load a memory variable, let's say memory variable 20, memory word 20, and this time you need to multiply by 200. Let's say I'm giving a speed reference from 0 to 100, so whatever value I am giving should be multiplied by 200. So I loaded multiply by 200 integer, then I transfer to the directly to this PQW514. So that's it, the program is done. So your drive, everything is ready. Okay, so now let's download all this. I'll download the complete thing. See. So everything is ready, so we'll download the complete project. So as you can see, I have the values coming from the drive, so this means the drive is ready for on. It's not ready for run, so what you can do is we can reset this bit. So let's add some bits here. So M0.2 will be the reset command. So M0.2, then M0.1 is the start command. This is the start command. Then MW10 is the speed reference, sorry, speed feedback. Then MW20 is the speed reference. Okay. Okay, so first we will reset the drive. Reset command should be like a pulse, so just an on off pulse. So now you can see the drive is ready for, there is no fault. Okay, so now if I give a start command, the drive is going to run. Okay, so let's give a start command. Yes, so drive got the start command. So you can see the status word change and drive is already running. But you can see the speed feedback is still 0 because we have not given any speed. So let's give a speed, let's say 50%. So you can see the drive speed also increased to 50%. We can, okay, so my motor is 1430 rpm, which means the speed reference I gave is half of this, so it will be 750, and speed feedback is also 750. So if I give a negative reference, the drive will again go to negative value. So you can see the drive is reversing, and my drive is also reaching the negative 50%. So if I give 100%, the drive is going to run in full speed. The drive is reached the full speed RPM. Now if I give a stop command, it's going to stop. Sorry, this one. It's decelerating and stopping. So this is a quick video about how to start and stop the drive from Siemens PLC. I hope this was, you already understood all this. So thanks for seeing this video. Have a great day, and yeah, okay, thank you.